So here's another reason we can justify the value of log 2 or about 0.69. So if we take this is what our claim is, so this is going to be a visual proof. We're claiming that this alternating series, harmonic series, it's got an n plus 1 because we're starting it at 0, but this alternating harmonic series, its sum is log 2. Okay, so we start with our 1, we take away a half, and then we add back a third, so it looks like this. Okay, so we take away a quarter, so I take away this one strip, and I add back 1/5. I take away 1/6, so I take away half of that 1/3 here, and I add back in 1/7. Okay, so I take away, add back into these little strips here. And as I keep going, I'm going to take away 1/8, which is half of this 1/4. Okay, so I'm going to take away this strip and add back a 9th, so I get back up to here. So it doesn't ever quite go back up to the top. Same thing here, I'm going to take away half of the 1/5. Okay, so I'm going to take away this whole strip and add back not quite as much. And we're doing that for every single strip now. And you can see that if we continue this pattern, we're going to end up with this strip that we're having. It's going to follow this curve. Okay, it's going to follow this curve. It becomes smaller. This kind of area that's above the curve is going to get smaller and smaller and smaller because we're going to take away and add back in, and these strips are going to get thinner and thinner and thinner. And just like with Riemann sums, we're going to end up with this area underneath this curve. Well, this curve happens to be the 1 over x curve. Okay, so this is the 1 over x curve here. Okay, so this is y equals 1 over x. And so then this area as a finite infinite sum is going to fill up this space underneath this line. And that area under that curve is just the integral of 1 over x. So if I integrate 1 over x, it looks like this. I get log x from 1 to 2. Log x from 1 to 2 is log 2 minus log 1. Well, log 2 minus log 1 is log 2. So this area under this curve is log 2. We know this for fact from integrals. And this infinite sum that's taking away and adding back in, this alternating harmonic series, will fill up this curve just like with Riemann sums is, but eventually it's going to fill up this curve nice and smoothly as we do infinite sums here because we end up with infinite bars.